All right, our next speaker is Dr. Khandekar, and he worked for Environment Canada for many years, and as he told me, he's now retired, but somehow during retirement, this whole thing on global warming and all this kind of data and how it's shared grasped his attention, and so now he's just hooked into the whole scene, and he'll share his thoughts with us.
Can you hear me all? Thank you, Senator. Some 25 years ago, when I was working with Environment Canada, I did a fair amount of work on El Nino, La Nina, and its global impact, especially on Canadian temperature, US temperatures, and as Senator would verify, this year's La Nina is causing some 25 degrees below normal temperatures in Minnesota, and I also did work on Asian monsoon and its linkage to El Nino, La Nina. I think 25 years later now, I see El Nino, La Nina research is taking a back seat in some ways, and everybody is pushing the global warming button. And we are now asking ourselves, global warming is linked to extreme weather. I had to look back to my data and analyze it, and the title of my talk is No Discernible Link. I will give my talk in this synopsis. I have a large number of slides, but many are sort of show and tell like, so please bear with me. Some basic definitions and facts. Global warming is the warming of the Earth's surface due to atmosphere above it, increasing concentration of greenhouse gases. Climate change refers to a change, either gradual or abrupt, average weather experience at a location. Now, based on a careful analysis of data, we all accept that the Earth's mean temperature has warmed by 0.6 degrees in about 150 years. Atmospheric concentration of thanks a lot. Atmospheric concentration of greenhouse gases, methane, nitrous oxide, have increased rapidly in the last 25 years. These are observed facts. Prevailing hypothesis. The present Earth surface warming is intimately linked to the greenhouse gases. This warming will continue in future, leading to increased incidences of extreme weather worldwide. Uncertainty is the link between warming and GHG is not unequivocal. You may have heard lots of talks this morning. Link between global warming and extreme weather is tenuous, and that's the main purpose of my talk here. I have a couple of brief global warming historical notes for the benefit of the seminar here. It was French mathematician Fourier who first put forward the concept that Earth acts like a greenhouse. Arrhenius, the Swedish scientist, estimated how changes in global concentration of carbonic acid would increase the mean temperature. Arrhenius estimated that increase in CO2 concentration by a factor of 2 would increase the Earth's temperature between about 5 and 6 degrees. It was a very rough estimate that time. American geologist Chamberlain studied the process of CO2 emissions into atmosphere for volcanic eruption, absorption, etc. Now, work of Arrhenius and Chamberlain did not receive support since absorption of long-wave radiation by water vapor was considered too strong. So nobody really felt that CO2 would really change the temperature of the Earth so drastically. It was a British engineer Callender who showed in laboratory that CO2 does have important absorption bands outside of the water vapor band, which we all now say between 15 and 17 micron. And it was his study that led to this hypothesis, or then eventually people started to look at this. Now, American geophysicist Roger Revelle proposed that humans are carrying out a large-scale geophysical experiment through worldwide industrial activity, which could lead to buildup of CO2 greater than the CO2 production from volcanoes. Revelle established CO2 monitoring station in Hawaii in 1956 and later at South Pole. Now let's look at some numbers. In 1750, CO2 concentration has increased by 31%. Other greenhouse gases, methane 151%, nitrous oxide 17%. We all agree on that. Direct radiative forcing of greenhouse gases, roughly about 2 watts. Solar radiation at the top of the atmosphere, 343 watts. But solar radiation under average cloudy sky. Now, that's not easy to take. So I think Ramanathan has done an excellent work some 10 years ago, took average cloudy skies and determined that there is a negative 18 watts per second meter. So if the globe is covered by more clouds, there is a feedback. And a lot of people are talking about that. Now let's see the observed warming of the Earth's surface. This is from 1860 to about 1999, and this is the CO2 as measured at Hawaii and elsewhere. Previous CO2 is mostly estimated through ice core and other data. Now what you see is that temperature doesn't go uniformly. You see, there were ups and downs here. The temperature went down here, up here, and the steepest temperature rise was from 1910 to 1945. And then again, temperature was cooling, and it was just the last 30 years that you see some sort of a relationship or close link, as we all call, between warming and CO2. The next is the global mean temperature as IPCC 2007 graph. This is 1 dot per year from 1860 all the way to 2007. You look at this dot, this is 1998 dot. From then on, there is a small but definite decline. And as we are all talking this year, in 1 year from January 2007 to January 2008, the Earth's temperature has declined by 0.6 degrees. All the warming of last 100 years wiped out in one small year. This is how the nature is so complex. Now I give you an example of Canadian temperature changes. Yes, we all agree winter, spring, Western Canada has warmed, especially Northwest Territory and subarctic. Look at Eastern Canada, it has cooled. Winter, spring, etc. So what do we see? A picture. Half of Canada, or maybe a little more than a half of Canada, has warmed, we all agree. But still about 40% of Eastern Canada has cooled, and cooled rather significantly. If CO2 is warming everywhere, why there is significant cooling? So the point I'm making is that there are other atmospheric processes, large-scale circulation changes. NAO is probably responsible for this. That also impact temperature patterns. This is just for Alberta. And as probably you may have seen from many other people, what is the climate of Alberta? January, February, March has warmed. April, not so. May, June, July, about same, while fall has cooled down. So if I want to describe the climate of Alberta today, it's going back to, say, 1950 to today. Yes, winter was very cold in Alberta in 60s. I lived in Edmonton in 1970s, and I experienced a temperature of -35 to -45 for one whole week, you see. Now it doesn't go that cold. So I ask you, is that a harmful change? I think I call it a beneficial change. Now, media hype, you have lots and lots of it. I will just give few examples of the Canadian media. Climate change in Canada, a bleak forecast, 1997. Weather worse than it used to be, scientists, 1998. Oh, I'll just go back quickly here. Canadians want to brace more extreme weather. Arctic meltdown. So all this media is creating this sensation. Climate at record extreme, 2005. Why 2005 as Hurricane Katrina, among others? I could have given this sort of big title in the year 1935, if we were sort of concerned about global warming then. And 1935 was, in my opinion, a very extreme year. Anyway, this is the IPCC table of extreme weather events. So what they are saying is cool days, cool nights, likelihood the trend occurs, certainly, typically, very likely, high. Warm days increasing. Warm spell heat waves increasing. Proportion of heavy precipitation events increasing. Droughts increasing over low latitudes, and primarily in what is known as the intercontinental drought, mid-continental droughts, like the Canadian prairies, Sahara, and Australia, and so on. These are the main three continents. Europe has essentially very little problem of droughts over the last 100 years. And middle latitude, high cyclones, etc. Now let's look at each of these, or trends in extreme weather. I'll first show a few of them for Canada. Palmer Drought Severity Index is a measure of drought. What I show is that 4 stations in prairies, low values is drought, high values is good rains. So you will see that the droughts have been occurring over prairies for hundreds of years. Same is true for American Midwest. So, okay, I think this is the drought one. Let's go quickly to the next one. Average number of heavy precipitation events over locations in Canada, south of 70 degrees. So we had some high precipitation events, snow events, and then it became lower, actually. So right now, number of events of heavy precipitation events are on the decline. 5th percentile of daily minimum temperature, 95th percentile of daily maximum temperature. What you see is that in the early 1910, minimum temperature was very low. Then it started to go up. And it is now the minimum temperature that is higher than what it was some 40, 50 years ago. Maximum temperature was highest on the Dust Bowl years of 1920s and 1930s. The next one is more graphic. This is a heat wave in Canada, the deadliest 5th to 12th July, 17 July 1936. Throughout central Canada and southern Ontario, 1,100 people died. Toronto recorded 41 degrees Celsius temperature 3 days in a row, and then 36, 37. And just in southern Ontario, about 250 people died in a matter of about 3-4 days, just of sheer exhaustion. They didn't know how to cope with some kind of a weather like that. Tornadoes, the most tornado-prone regions in Canada is Alberta and Saskatchewan. And this is the data source of Professor Haig, Emeritus. He has analyzed a large number of farm newsletters going back to 1880. And this is what he finds. The Dust Bowl years had high occurrence of tornadoes. Then they declined, and this increase is primarily because of awareness to tornadoes. More tornadoes are being reported than they were reported before. But look at the number of intense tornadoes. They are on the decline. Let's go to extreme weather trends over USA. And I have a few slides from here and there. This is a graph from Napenborough, Michaels, etc. So the US temperature history, 1910 to 30, very hot, 40 to 50 cooler, and now we have the heat season. Some of the hottest summers in US were 21, 33, 36. I think more recently, Stephen McIntyre identified 1934 as the hottest summer in USA. And my own assessment is that if we have worldwide data, then I think 1934 to 36, one of those years could become hottest in the entire world. This is an excellent data by Stanley Shanyo. What it shows is the highest one-year value of thunderstorm, lowest one-year value of thunderstorm. So during the Dust Bowl years, highest values were reported at up to 15, 20 stations. Then the number of values declined and it's slightly coming, while the lowest number of values reported at more stations were in the 60s and 70s. This is linear number of thunderstorm day values, 1896-95. I think everybody knows that Tampa is the lightning capital of North America, or for the world for that matter, but there is a slow declining trend. Then 2 other locations, Abilene, Texas, and Green Bay, Wisconsin. There is not much of a trend here. This is the hurricane data from Chris Landsea, Atlantic intense hurricane. You see there is an interdecadal trend. Strongest Atlantic hurricane wind speed, there were higher wind speeds in 70s, 80s. Then there is no consistent trend. That's what I want to point out here. This is US one-day duration extreme precipitation. Kenneth Kunkel's data at Illinois State Water Survey. Yes, one-day return period, this does show a trend, increasing precipitation intensity. But if you take 5 days, then the trends are There were trends in 1890s. So part of that variability could be natural. This is tornado reports F2 to F5. Yes, there were more tornadoes in 60s and 70s, then they declined, and now we see more. But quite possibly, more tornadoes are being reported because improved monitoring technology. Not necessarily, but the intense tornadoes are definitely on the decline. And give you an example, 1974, April 2 to 4, I think the highest number of tornado outbreaks in the United States, something like 200 or so in matter of 2 days. And that time, the mean temperature of the Earth was declining, not increasing. Shifting economic impacts from weather extreme in the United States, a result of societal change, not global warming. A very venerable climatologist, Stanley Shannon's work, it appeared in Natural Hazard special issue, of which I was a guest editor. I want to go elsewhere in the world. Tropical cyclone, Australian region, intense and otherwise. Tropical cyclone, Western North Pacific, there was a increase, then decline, and now we show an increase here. Asian monsoon region is the largest seasonal anomaly in the Earth's climate system. Present climate models can neither simulate nor predict monsoon precipitation. Indian monsoon region, major droughts, major floods. Major droughts going back to 1918, 51, 72, 87. Major floods 1892, 1917, 1933, and so on. The point I'm making is that droughts and floods were occurring in the Indian monsoon region and by proxy in other parts of the Asian monsoon region for hundreds of years. And they were not activated or influenced by human activity 125 years ago. So there is no reason to believe that they are being affected now. I have another slide about Indian monsoon. Okay. It sometimes acts funny on me. I went a bit too far. Indian monsoon exhibits decadal variability. This is the year-to-year annual. But if you take the T statistics, Kramer T statistics on a running means, what you see is that for some years, Indian monsoon is above normal, then below normal, above normal, and so on. So it is unaffected by global warming at this point in time. This is storm surge-related deaths in Bay of Bengal region going back to 1584, 1991. This is Dr. Murthy's data. He has collected data from Mughal Empire period going back to 1500, and this is what he finds. I have plotted only selected deaths when the death exceeds high value like 200,000 and so on. You can see it's staggering, you see. Even in 1737, there were deaths as high as 300,000. More recent, 1970, Bay of Bengal tropical cyclone killed 270,000 people. And that time, the mean temperature of the Earth was declining. So there was no hue and a cry about, oh, so many people are dying, something is happening. But it's only now that it has become a little bit of a fashion. Okay, South African rainfall variability, you see it's up and down. There is no trend here. South African rainfall variability is governed by large-scale floods, flow pattern, and others. No impact of global warming. Final couple of slides. Australian rainfall variability, 1 to 4 meter low intensity events seem to be increasing, but the high intensity event like 25 1-inch rain, almost about the same. I have an interesting slide here. Cold season extreme weather events seem to be on the rise. Look at winter 2007. Southern Hemisphere had snowfall in Buenos Aires first time since 1980. South Africa had major snowfall July 2007. 2008, January snowiest in Northern Hemisphere in 1966. Severe cold spell in Middle East, Eastern Europe, China, and so on. Winter 2005, very cold in parts of Russia. Winter 2004, very long and snowy in eastern Canada with several blizzards. Winter 2003 and 4, Halifax received 100 centimeters of snow in one single day. the largest ever. In St. John's, Newfoundland in 2000 were highest amount of snow accumulation at a sea level location, 650 centimeters. At mountain locations, you have 2,000 or more, but at sea level location, no other place has that much snow recorded in one season. Okay, come to summary. Heat waves, summer maximum temperatures are not increasing anywhere in USA, Canada, or elsewhere. Intense precipitation events show increasing trend over USA, but not over Canada. Elsewhere, trends are mixed. Natural climate variably increased sea surface temperature and local regional influences are considered possible. Thunderstorm tornadoes in North America peaked during the Dust Bowl years, and they have now declined. Intense tornadoes are on the decline in recent years. Thunderstorms show no increase. Indian Ocean monsoon variability is governed primarily by large-scale features and not by global warming. Mid-continental droughts, North American prairies, as well as Sahel, are primarily governed by worldwide sea surface temperature distribution and not by human activity like global warming. Tropical cyclone, hurricane, typhoon exhibit strong decadal variability, do not appear to be influenced by global warming. A final slide of conclusion. Extreme weather events have been occurring for hundreds of years in the Earth's climate. Recent awareness and increased media attention have created a perception. Extreme weather event occurs with about the same frequency as present during the 1945-1977 period, where the Earth's mean temperature was declining. Extreme weather events as identified by IPCC are not increasing anywhere at this point. Likelihood of extreme weather events increasing in the foreseeable future remains small. Interestingly, cold season extreme weather events are increased in recent years, for which neither the IPCC nor the climate models offer any plausible explanation. That's what I have to say. Thank you very much for your attention.